Today we are going to be talking about lines of symmetry, and you are going to get some new figures, more complex shapes where you need to identify the lines of symmetry. So first let's review what are lines of symmetry. Read this definition with me. They're lines drawn through a shape so that it is the same on either side, or in other words, one side is a reflection of the other. So my helpful tip is always to use the folding test, right? If you could fold the shape over that line and the sides would match up perfectly, that shows you have a line of symmetry. So here are some, these should actually say line segments of symmetry, right? Because we know if we wanted them to be lines, to use our geometric terms, we would need to have arrows on them. But alas, we left those out. So maybe these are line segments of symmetry down here. However, they still illustrate the folding test or that reflection or mirror of each other, of the sides um, on, on either side of the line. So you can see a perfect square has 1, 2, 3, 4 lines of symmetry, right? But then when you look down at this quadrilateral down here, this parallelogram, it actually has no lines of symmetry, right? And I could try that with my folding test if I tried to draw one here, but then imagine I fold it along that line. Do you see how this part would jut out over here? And that's not where, like this part here would jut out over here, and that's not where it is on our shape. So I'm going to cancel that, go back, get rid of that, because that one has no lines of symmetry. And this trapezoid here only has one, right? But then you see a lot of other shapes depicted here that show you multiple. So if you need a moment, pause the video. You could study each of these shapes and really analyze, do those lines of symmetry make sense? Have we captured all of them? Which we should have to my best knowledge. Now, a little challenge for you. Look around your room and name an object in your room that has, whatever room you're in, that has at least 2 lines of symmetry. And play back the video when you're ready. I was looking at my window frame, which is in a square shape. And then I guess I had a lot of squares because I was also looking at my door. Although if you counted the door handle, then it wouldn't be symmetric because the door handle's not on the other side. But at least the door frame is. Okay, I hope you had fun with that challenge too. So now we're going to look in the context of a quilt. And this is actually on page 280 in your math journal. So you could follow along on the screen or on page 280 if you want to get some extra practice after this video. Well, what do you know about quilt making? Maybe some things you're thinking are that quilts are often in a square or rectangle. However, they have different shapes and patterns within them. A lot of the patterns repeat oftentimes. So we're going to look at some samples from quilts and analyze the lines of symmetry in them. So this quilt pattern is called a pinwheel pattern. I'm going to show you a few different ways. So in this first one, none of the triangular sections are colored in. So this is just like the square we were looking at a moment ago. So you can know right away that this is going to have 4 lines of symmetry. I just drew 2, and then 3, and then 4. All right? Okay, now it gets a bit more interesting because there's some shading done on the triangles. And remember, the sides need to match up exactly. So now we can identify 2 lines of symmetry, or again, I guess I should say line segments since I'm not drawing my arrows. We could identify 2 lines of symmetry right here. but the diagonal ones go away. Can you think about why? Well, now that it's shaded like this, let's say I drew one of the diagonals. Even looking at this piece and this piece, do they match exactly? Because one is shaded and one is empty. So that one only has two. Let's go ahead now. Oh, this is a whole new shading pattern. And because of the shadings, we're only able to have one perfect line of symmetry. Let's try another one. Maybe if I wanted to try this one. Okay, so I notice here and here, mine match up, but here and here, this triangle's shaded and this triangle's empty. So that would not be a line of symmetry. Let me get rid of it. Okay, and this last one, oh, now you can really start to see why this is called the pinwheel pattern, right? And this last one, there are none. Let's go ahead and try one. If I drew one across like this, uh-oh, I already see, right, an empty and a shaded right on the opposite sides of the lines of symmetry, so that would not work. Let's try another one. Let's try this one. Uh-oh, same problem. A shaded and an empty. So this figure is not symmetric at all. I may have given away the answer to this question, but all of these squares technically show the same pattern, same number of triangles, I should say. But why do they have different numbers of lines of symmetry? Well, as you may have concluded already, they have different shadings, and that affects the symmetry. So the shading of the triangles affects the symmetry. You have to have a mirror image on either side. So keep that in mind as you head off to extend your knowledge of lines of symmetry. Hopefully this review was helpful.